Long, and I'm going to teach you about the Coriolis effect. We live on a rotating sphere, the Earth, which rotates from west to east. This produces the Coriolis effect, which is the apparent deflection of a moving object in a rotating reference frame.
We call this an apparent deflection because the object does not actually deviate from its path, but just looks like it. For example, let's look at a merry-go-round. To an observer above, a ball thrown on a rotating merry-go-round appears to go straight, but to the people sitting on the merry-go-round, the ball's path is deflected.
Because Earth is rotating from west to east, the path in the northern hemisphere is deflected to the right, and the path in the southern hemisphere is deflected to the left, as you can see by these arrows. Also, pilots must consider the Earth's rotation when flying over long distances. Because of the Coriolis effect, most planes cannot be flown in straight lines, even if the airports are directly across the continent from each other. For example, the line between Portland, Oregon and Portland, Maine is very long and almost straight. However, flying east, the Coriolis effect would deflect the plane to the right in a southerly direction. Therefore, if the Oregon pilot flew in a straight line, the plane would end up near New York or Pennsylvania.
The Coriolis effect also causes something known as Ekman transport. Ekman transport is the net transport of water due to the coupling between wind and surface waters. Transfer of energy from wind to water decreases with depth. You can see from this demonstration that the surface water moves much more than the water below.
Also, because the Coriolis effect deflects the wind, it also deflects the layers of water beneath. This results in the net transport of water 90 degrees to the wind direction. Therefore, if the wind is going in one direction, Ekman transport will cause the water to be deflected at a 90-degree angle, either to the right in the northern hemisphere or left in southern hemisphere.
And now you know everything about the Coriolis effect and Ekman transport.